The system of linear equations Ax is equals to 0, where A is an n by n matrix, has a non-trivial solution only if. Now, he has given a system of linear equations which is defined as Ax is equals to 0, null matrix, and A is of order n by n, has a non-trivial solution. This system of linear equations will have non-trivial solution. Then he's asking what is the property. Now, it's a straightforward question which is nothing but the properties of non-trivial solutions. If rank of A is less than the order of the matrix, which is n, then only the non-trivial solution exists. So the answer is option C. Normal vector to the surface of the sphere x square plus y square is equals to 1 at the point 1 by root 2 comma 0 comma 1 by root 2 is. So we have to find the unit normal vector along a sphere whose equation is given and at a point 1 by root 2 comma 0 comma root 2. Now let us consider the function sphere as some f. Consider this function as x square plus y square plus z square minus 1. Let us find the divergent of this. So summation of dou by dou x of x square plus y square plus z square, which can be written as 2xi plus 2yj plus 2zk. Now we need at some point 1 by root 2 comma 0 comma 1 by root 2. If we substitute, it will be root 2i plus root 2k. Now unit vector along this is nothing but root 2i plus root 2k by root over root 2 square plus root 2 square, which is nothing but root 2i plus root 2k by 2, which can be written as 1 by root 2 times of I plus 1 by root 2 times of k, which is nothing but option B. Find the integral value of 0 to pi by 2 log of tan x dx. So let the given integral be some I, 0 to pi by 2 logarithm of tan x dx. Let it be some equation 1. I is equals to 0 to pi by 2. You can write this as logarithm of tan pi by 2 minus x dx. Since integral 0 to a f of x dx can be written as integral 0 to a f of x minus a dx. A minus x dx. Now this will be 0 to pi by 2 logarithm of tan 90 minus theta is nothing but cot theta. So this will be cot x dx. Let it be some equation 2. Now we'll add equation 1 and 2. That is 2i is equals to integral 0 to pi by 2 log tan x plus integral 0 to pi by 2 log cot x dx. This can be written as integral 0 to pi by 2 as it is common logarithm of tan x plus logarithm of cot x dx. We know that log a plus log b is nothing but log of ab. So this will be logarithm of tan x into cot x dx. Tan and cot are reciprocal, so the value will be 1. So 0 to pi by 2 log 1 dx. Log 1 is 0. So the entire integral will become 0. Hence the answer is A.
The transfer function of a pure dead time system is. Here dead time is tau d. Here coming to the explanation, dead time system means it is kind of a delay system providing the delay. Means suppose x of t is the input, y of t is the output, which is equals to x of t minus tau d. Here then what is the h of s? Here nothing but h of s is nothing but a delay providing system which is equals to e power tau d s. Hence option C is correct. Question is, for a feedback control system to be stable, here coming to the explanation point of view, if we plot the, suppose it is S plane, j omega axis and the real axis. For the closed loop system to be stable, the roots of the characteristic equation must be in the left half of the S plane. Whether it may be real or complex, but it should be in the left half of the S plane. As if the roots are on the left half of the S plane, then the system is going to be stable. If comes to option A, roots of the characteristic equation should be real. No, it's not correct. Option B, for poles of the closed loop transfer function should lie in the left half of the complex plane, means S plane. Hence option B is correct. The unit impulse response of first order system is given as 2 into exponential minus 0.5t. the DC gain and the time constant of the process are respectively. See, h of t is given as 2 e power minus 0.5 t, means h of s equals to 2 by s plus 0.5. First of all, the DC gain is nothing but s equals to 0, that is frequency equals to 0, it is 2 by 0.5, that is equals to 4. Whereas time constant equals to, if we arrange the equation in this form, because it is a first order system, here we will get 4 by 2s plus 1. The time constant is equals to, if we compare this and these two equations, we will get the time constant tau equals to 2, which is option A is correct. Is if EB, TB and FC respectively denote bit energy, bit duration and the carrier frequency, the signal is um of t equals to under root 2EB by TB bracket cos of 2 pi fct cos of m pi by tb into t minus sin 2 pi fct sin m pi by tb t into this. Whereas m taking values 0 and 1, whereas t is the t limits are in between 0 and tb represents what? See, whatever the equation we have here, if we compare with the standard equations of the phase shift keying, then we are going to know that this equation belongs to a binary phase shift keying, because here m taking only binary values, either 0 or 1. Hence option A is correct. Option is an analog voltage is converted into 2-bit binary number. So the minimum number of comparators required and their reference voltages are option A 3 comma V by 4 V by 2 3 V by 4, and option B 3 V by 3 2 V by 3 V, and 4 V by 5 2 V by 5, and 3 V by 5 4 V by 5. Option D 4 V by 4 V by 2 3 V by 4 V. See, if we want to convert any analog voltage into a 2-bit binary numbers, means how many, means we have to represent an analog voltage with 4 levels, because each level can be represented with a 2-bit binary number. So because see here, suppose assume this is a comparators, we are using opens as a comparators here. Now what I will do is, here this is some resistor R, another resistor R, another resistor R. This is analog voltage. Now R, this is V reference voltage VR. If this is the circuit, by using some other logic encoder or some kind of encoder, we can produce, or some kind of a ROM, we can produce output as a 2-bit binary number. Two-bit binary number So if we go through this answer, how many comparators we require? 3 comparators. How many voltage, reference voltages are required? This is V by 4, this is V by 2, this is 3V by 4. So option A is correct.